Thank you for coming. Yeah, it's really early for this type of thing. I just had my coffee, so I'm ready to program. So I wanted to do something different. DevGAMM is this nice conference where we do things differently. There are like new formats that are more interactive, more outgoing. And I feel that a lot of the time, last year here, I was here and talking about my game MacPixel 3 and how I ported it to, like, can you see that? To all the platforms, while I made the engine from scratch in C. A lot of you probably started making games using Unity. A lot of, I guess most game developers started making games using some kind of an engine that has an editor, something visual, something that you can, tangible, right? And I feel that this kind of created an environment where people are now afraid to go back to the place where we had to type code to start anything, to show the window. And I want to show you that it's not hard, it's easy. I'm going to make a game in 45 minutes right here, right now, and show you how to do it. To kind of take off the, the stigma, the fear of just being afraid of going into C like a native language that compiles and can segfault. Hey, can I have less of these lights in my face? It's like really in my face. So we're going to make a game that's really simple. This is Allegro.js is a library that I created. It's like a library called Allegro. That's old C library for making games. When I started using this, and this is the tutorial game for this. It's very simple. You have this fly splatter, and you splat this fly, and then it goes splat, and then it goes splat, and then it goes splat, splat. And this is what we're going to make. It's like the simplest thing ever. It doesn't even count the score. But what I want to do is to show you that we can do that from scratch in C with nothing to start. So what we will do is we will set this to this half of the screen, and we will set this and create a new project, absolutely empty project. We will call this window splat or whatever. We will create the empty project. Creating the project. All right, here is our thing. To hide all of this. So this goes to the side of the screen. And on the other side, I will have this with a documentation. I have screenshots of documentation, so it will be easier to get around. Hey, can I really have this light off, please? It's like I can't see my screen. Thank you. All right. So what we will start, this is an empty project. There is absolutely nothing inside. What we will do, we will create a new file, add new item, and we will call it, we will use C language. So it's going to be main.c. That's it. This is our main file, the entry point to our application. And if you know C, if you learn C, you know that we start with include. Include what? Windows, because we are using windows.h. A lot of the things I would like to have them on the side of the screen so that we are using these the documentation, but some things might be alien to you, especially if you don't use C. So don't worry. If you have a question, you can raise your hand whenever and ask me to clarify something, because I want this to be clear what we are doing here and why. So we are including Windows to have functions for opening the window. We are including the standard io.h. This will allow us to use the standard functions of the language. And now we start with the entry point. That is main. It's called int, not main. Int, and it has two parameters. One is the integer count of the arguments, and the other one is an array of strings of the arguments. That's called argv. And what the function does is return 0. That's it. And now we press F5, and we have an application that does absolutely nothing. It should open a window that's empty. Probably open on my second screen. This is it. This is our application. It's done. It's working. We have our first program. So what we want to do first, we want to open a window, then we want to load an image, then we want to paint an image into the window, then we want to get mouse input and control this fly splatter, and in the end, we would like to have some sounds. So we start with creating window. Can you see the letters fine here? All right. So CreateWindow function returns something called a window handle. I was thinking about a lot about what kind of library should I use for this, but I decided to use no libraries at all to show you that it's simple. Create window. That it's simple to create a game with nothing, even if you use no libraries. Of course, you have a million libraries that will help you out, but we will not use any, and we will still do that. So the parameters are the class name. We will call the class sauce. The window name. We'll call the window sauce. Now we have, come on. Now we have style. And the style is window style overlapped window. This is something, if you scroll down on the documentation, it's right there. Then X, we will use the default. Wait, that was use default. And Y is going to be use default as well. And then width is going to be 640. Height is going to be 480. The parent, there's no parent, so 0. Menu, no menu, 0. H instance, we need the instance. We will create it in a moment. Let's do that. The instance is the handle to the application, and we don't need a param. So what we need now is an instance. How do we get instance? But before we do that, we want to handle errors so we don't scratch our heads, right? So what we will do, because this can create the window handle, but it can also return null, and then we can use getLastError. So we will make a short function that will handle errors for us. So we're doing it the right way. Check error, it's called. So what it will do, it will dword error equals getLastError. And then if, now check this out, what is the value if there's no error? If error is equals error success, that's what the success error is called, then we return because nothing happened, okay? But if not, we do. Now we will get only a number, and we will have to look it up. But we can get the error code and use the function format message. So we will create a buffer for our string, char buffer, with a length of this is enough. And now we will format message with flags. Oh no, I forgot what flags are there. Format message from string, yes. And the source is, there's no source. And the message ID is the error code. And the language ID is I don't care. And the buffer is the buffer. And the size of the buffer is 512. And the arguments are 0. And now we have our string in the buffer. What we can do is we can display a message box with the window handle. No, there's no window handle, so 0. With the text from the buffer, with the caption of error, and with the type of message box OK. So it has a button that says OK. And on top of that, we will printf. So we will just print to the console the string of the buffer with the new line char. That's it. That's our error thing. One more thing that we have to do right now is go into the project settings, properties, and we will change. So Windows by default uses Unicode. So it's not the Unicode that you think. It's not UTF-8. It's UTF-16. So that's like every single character has 2 bytes. When we change that to multi-byte, we can use normal string. Otherwise, I would have to convert that into 16-bit strings. All right. So now we have our error correction, and we can check error. And there's an error right here because it's underlined. Instance is undefined, but we will get the instance. So instance is the handle. Windows uses handles, and it's the handle of the current module, which is the current application. So instance equals get module handle. In Windows, if you don't know what to put in a parameter, you just put 0, and that's all right. And it says optional, so that's all right. Great. So now we have that, and we can run it, and it will do nothing because it should display an error. Oh no, get module handle. It's handle. And now we create this, and we get nothing. We get error in error. We don't need this. Access violation, all right, whatever. But the thing is that we don't have, I wanted the error to happen, but we don't have a thing called window class. So the second parameter of the CreateWindow function, the first parameter is the class name. And in Windows, you need to create a class for every window you create. And it's very simple. You use the register class function, and you pass it the window class structure. So what we're going to do is create the structure now. Window class. Look, we can use this because it's not a keyword in C. And we will initialize it. First, we need instance. That's going to be our instance. And we need the class name. Oh no, there's supposed to be a comma. We need class name, and the class name is Sos. And what else do we need? I think nothing. The window class looks like this. We need style. Oh, and we need the WindowProc. The WindowProc is like going deeper and deeper. Is a function that handles all the events that happen in a given application. So what we want to do is we want to create it now. And to create it, we go to the documentation, and we have the prototype. So we create the lresult WinAPI WindowProc that has parameters. The window handle, we call it H for short, because we have the HWND here. uint. It would be simpler if I knew how to type the message that we get. Then we get WPARAM. And we get the LPARAM. There are two params. And that's it. And what this function does by default is we return the default WindowProc that the system provides for us, and we pass them all the arguments. MSG, WPARAM, LPARAM. And that's it. So now we have it passed here, and we have this. And when I play this now, it should create a window for us. Let's see. It should also close the window immediately because there's no wait. Why is this a... Why is this an error? Format message. I did the format message wrong. I will just disable this for now. We will have no errors. All right. So now we have the window. We need to show the window. That we created it, it doesn't mean that it's shown. It's hidden. It's not like hidden, like it's minimized. It's just like not there at all. We will show the window with our handle, and we will show it with 1. And that's it. And then what we need is a loop. So now, look, we will create the window. We'll create the class. Oh, we need to register the class. I forgot about that. It was before a bit. Register class. So we register the class called class. And that's it. Now we use the class. And now we show the window. And now we check the error. We don't check the error anymore. But now look, we will create the window. We will show the window, and the application just exits. What we want to do is we want a message loop. A message loop is like we get the message here. we translate the message and dispatch the message. And this gets the message from the system. Like, for example, I moved my mouse over the window, I clicked it, I resized it, I closed it. All these messages I need to handle in my applications. Like, things need to happen. Like when you resize the window, you need to resize the playfield of your game and stuff like that, unless you do not want the window to be resizable, which is also a thing. So what we will do is we will create an endless loop with a quit parameter that goes to 0. And while the quit is 0, we will loop. And now if we will not use getMessage, because getMessage will stall. It will wait until the window gets a message. This is for applications. For a game runs even if it doesn't get messages. So we use peekMessage. It will peek into the message stack and see if we have anything. We need a message parameter that we will pass here as a pointer. And now we pass the window handle. And now we pass, 0, 0. And we remove the message. So it doesn't stay on the stack. And then we translate the message. I don't know why. Don't ask me. Translate message. And we translate the message that we got. And after that, we dispatch the message, and the dispatch calls our WindowProc. And while this happens, and now in our WindowProc, we can check for messages. So for example, if our message is window message quit, or the message equals window message close, we set quit to 1. So when quit is 1, and this exits, it will go here, check for quit, and just go to return 0 and exit our application. Now I will press F5. Maybe we will run into some problems, but maybe it will just open the window. It opened the window on a second screen. Look at this. This is our window, and that's it. I close it now, and it exits. Right. So now the next thing. We pick the message, we did that. Now we want to load an image. We want to load, I forgot to copy the files that I need to load here. We need to load an image to be able to display it. So I have a bunch of files. Let me show them to you in a second. Just when I copy them to the right folder, we go to Windows Splat, paste them here. Look, so I have this nice image of a window, just a bitmap. I have this nice image of a fly. It's called Buzz. I have this nice image of a fly that's already dead when we kill it. I have this weapon that's really going to control the splatter. And then I have the weapon. When we press the mouse button, it goes down. That's all. That's everything we have for the game. It's not much stuff. Happy little bitmaps. And now we need to create our variables for this. So we go bitmap, the bitmap handle. And the bitmap handle to window will be 0. To the buzz, that's our fly, that's 0. To the splat, that's 0. Then we have weapon, that's 0. And weapon 2, that's 0. But we'll start small. We'll just try if we can load the window. Load image. So we need the instance, but if you can see here, the instance should be 0 if we are loading from the file, and we are. So we're passing 0 here. Then the name is our window file, window.bmp. And then the type is going to be image bitmap. Then we don't need this. It's going to read that from the file. And then we need fr load. It was, or lr, load from file. That's it. So now we are loading the window, but we also need to draw the window on our scene. So what we will do is we will create a render function. That's simple. So now the things got complicated because we were using the official Microsoft documentation, but to find out how do I render to window using WinAPI, I had to dig into our favorite website called Stack Overflow because I could not find any information anywhere on how to stack these functions to have them display what I want. And the answer to that is not exactly sure what is your problem. So this is very Stack Overflow things to say for a problem that I could not have solved without this answer. So we need a paint struct. We need this device context, it's called, and we need this bitmap to pass it onto it. So the way things work in Windows, like every system has it different. It kind of might feel counterintuitive, and every other system will have it in counterintuitive in a different way. But what I want to show here now is that even though this does not really make sense in the context of anything, it takes 45 minutes to create that. And every other system will take that much time to get from 0 to a thing you can display and interact with. So even though it's weird, it's not much work. So we will now do the render part. We need the paint struct. We don't need all of this. We will improvise, cut a bit of it. So but we do not need the paint struct, that's PS. We need the device context of the destination and of the source. And I think that's all we need. So what we will do, we will create the device contexts for the window using begin paint function for our window and pass the paint struct. Oh, but before we do that, there's also a thing where Windows is very optimized. So you need to mark the window as dirty so that it will repaint it. Even if we render to the window, it will not happen immediately because Windows want to save resources. So we need to invalidate. We will invalidate a rectangle of this window. We'll just pass 0 and 0 here. And it will invalidate the entire screen for us. So now we begin paint. Where is this? Oh, because that's destination, sorry, DST. This is our destination device context. And then we will create a compatible context for the source. So it has the same properties. And now we have the other device context, and to this, we will bind the bitmap. So we'll select object. And we select, for the source context, we will draw the bitmap window. And now we can paint using the BitBlt function. This is one of the things that made Windows so great, that you had this blit function. You could draw a lot of things you can do with that, right? We will paint to the destination at the point 0, 0, at the size of the screen from the source, and we will read the source from 0, 0, and we will use the src copy function, and at the end, we have to delete DC, our source context that we have created before. I don't know why you have to do that every frame, but it does not take away resources, so it's fine. And then we will end paint that we began for this window, for this paint struct. And now we have our render function. Look, we invalidate the window, we begin paint, and create a source context, and then we just draw the source to destination, and window will do all of that for us gladly. If we call the render function every frame, we will also add a sleep function for 10 milliseconds so that it doesn't overflow our CPU in this very tiny laptop. That's important. And now it opened the window, and it draws to the window. That's look, it took us 20 minutes to just open the window. Now, we will just use this loading, and we will load more. So we want to load the buzz. We want to load the splat. We want to load the weapon. We want to load the weapon too. We will just do Control-C, Control-V. That's every programmer's favorite thing. All right, so now we have all the graphics loaded. Now, two things that I want. One is the position of the fly. Let's start with 100. 2 is the position of the mouse. All right. So what's going to happen? Our render is also our update function. We don't worry about that now. So what I want to do is I want to render another image on top of that. So I will render the image called bus. And I will render it at the fly x and fly y. And I will also do something called seed rand. So normally you have a random function. You can use the rand, but I need to seed it. If I don't seed it, I will get the same value every time. And I seed it with a time value that's like kind of pseudo-random every launch. And now what I want to do is I want to fly. So fly x, I will add. Now this will look very C, but this is the simplest way to do that. I will add a rand. So a rand returns me a value from 0 to 64 kilo. But I will do the modulo of it because I want from 0 to 1, 2, and that's it, so 3. So modulo 3 can give me either 0, 1, or 2. And if I subtract 1 from it, I will get value -1, 0, or 1. And this way, the fly will either move or not. And with the other direction, we will do the same. So now it should load the fly, and it should display it at the coordinates that we've given it, and that's too big, because it's only this big. And this should work. Let's see. Look. This is our window, and on our window, we have a fly that's flying. But the transparent pixels are not there anymore. So what will happen now, we will create an error, but that's in a moment. We can, instead of this BitBlt function, we can use the TransparentBlt. So TransparentBlt works the same, but we need to pass 64 here as well. And instead of this source copy, we will pass the RGB value that we want to cut off. And in this situation, that's 64, 128, 128. And this should create an error in the linker. So what happens now is that this function is inside a library that's not by default. Like, system has a lot of libraries. If I use like DirectX, I need to link against it. It will not pull this immediately and automatically for me. So what I will do is, if you go here and you scroll down, you will see, like this is the documentation page, you scroll down and you see what kind of library it's in. So it's easy for me to just add it here. img32.lib. We will also add another one, that's WinAPI.lib. That one is going to be used for sound later, if we can get sound playing over the speakers. That's it. And now when I press play, F5, it should build, and I should have this really nice. This is working better than I expected. Look, we have flying. And we still don't have our error working, so if there's an error, we will not know what happens. So now, we have the window, we have the flying. Now we want to have our fly splatter. So what I want to do is, here in this, I want to create another event. But to that, I have the mouse, X mouse, Y, and left mouse button equals 0. So if the message is window message mouse move, ooh, that's two lists. This means our mouse moved. And now this is going to be a bit difficult. So if the message, because this system is like 25 years old that we are using here, even though this is Windows 11, this is going to work in like Windows 95 as well. But we have the low order word of the LPARAM is our upper left corner of the client. It's like I need to take the LPARAM now, and I need to dissect it into two values. So mouse X is going to be LPARAM shifted right 16 bits. Mouse Y is going to be LPARAM. No, wait, that's wrong. And 0xFFFF. This one is shifted, and that one is not. Shifted right 16 bits, and this is just 0xFFFF. So this way, with the mouse X, we get the lower 16 bits, and with the mouse Y, we get the higher 16 bits. Why did they do that? Because it's a really old system. but it works. Now, we will do another thing. If, oh wait, before that, let's check how well did we do. So we copy this, we paste it. Look, I don't need entities. I don't have entities here at all. You do not need that when you make games. And now we draw the mouse here, and we do not draw the buzz, but we draw the weapon. And now when I press play, I should have the splatter where the mouse is. Now you can see that the mouse cursor is there, and we do not want it there. So what we can do is we can call a simple function, show cursor. And in this, we pass 0. And for our application, there will be no more cursor. So we will just have our fly splatter. Now I don't see when it's on the, look. So now, two last things that we will do. Look, it's 30 minutes in, and we are nearly done. Two last things that we will do. We will splat the fly, and we will add sounds. So first of all, we have the mouse move message. Now we will create if the message equals WM, and it was called left button down. If we press the left button, we will set LMB to 1. But if we press the button up, we will change this to 0. And now, here, we can change the LMB. If it's pressed, we will play weapon 2. But if it's not, we will just pass the weapon. So right now, we should have our fly splatter doing a thing. Oh no, come on, window. I don't see the mouse in the window anymore. Look, it does the thing. And now we want to splat the fly. And the last thing we do, we will splat the fly. So when we splat the fly, what I do in this previously shown demo is I'm basically painting this bitmap onto the window bitmap, and that's what I'm going to do. So this way I can have infinite killed flies, and the game will not run like into performance issues, because these are not objects that need to be drawn. These are just a part of the bitmap. So thanks to that, we will be able to have people playing indefinitely. This is a game that has hundreds of hours of potential gameplay. So now we will do another function, and this function is called kill. Void kill. So what we will do in kill, look at how here we've been painting to the window. We will do the same thing, but instead of creating a context from the paint to the window, we will just create a context compatible to nothing. If we pass 0 here, it will be compatible to the desktop. And since our window is compatible to the desktop, that's going to be OK. So we're going to create 2 of these, destination and source. We're going to select 2 objects. The destination is the window, and the source is the splat. And now we will just call this TransparentBlt at the fly x and fly y. And then at the end, we will delete the 2 contexts that we created. Wait, this should be destination is window. Oh. And after that, after we drawn the fly, what this here does is it just assigns a random position to the fly somewhere else on the screen. So it just, you don't kill the fly. No flies have been harmed. We just do fly x equals random value. And since the bitmap is drawn from the corner, we will not do the entire 480, but 480 minus 32. And 6, yes. And thanks to that, our fly will move. So now, when we press the button down, we will check if the absolute value of mouse x minus fly x is less than 32. So I'd subtract it, and it's going to be from minus 32 to plus 32. But then I can do abs and just one thing. And the absolute value from mouse y minus fly y, the order doesn't matter because I do abs, is less than 32. So it's like a square kind of, like a box collision. We will kill the fly. Let's see if that works. There's like an error here because there's no and. All right, let's check this out. Here we go. It just works. And we are 35 minutes into this talk, and I spent a lot of time just talking. Oh no, where's the fly? Where are you, fly? Doesn't matter. OK, last thing that we will do. Why is this like this? Fly X? Yeah, that should be all right. Doesn't matter. One last thing that we will do is we will play sounds. Do we have sounds? Let me just check. The system, am I connected to the right? Yes. Test. All right. So I have here two sounds. Let me play them for you just in a second. They're called hit and miss. This is hit. And this is miss. All right. So to play the sounds in Windows, that's very simple. You do not have to load the file and keep it. You just play it straight from the file. So I just call play sound here. And the sound is going to be this hit dot wave. And the module for that is, I think, our window module, or maybe nothing. Just pass nothing. And the sound is going to be, oh, wait, this was supposed to be file name. I think it's S&D file name. Is that the module? Maybe. And then the sound is going to be, no, this is S&D file name and S&D async. So async tells it to play it, so it does not stall. Otherwise, it will have a hiccup. I think this is 0 just. Otherwise, it would have a hiccup. It would stop to play the sound. It will stop the applications, and you would have to develop like a message system or a multi-threaded thing to have that play. Let's see if that works. I wonder if I did it right. It doesn't play anything. Play sound, H module. What's the H module in play sound? Just give me a second and I will check. No, that's all right. It works, but it doesn't play the sound. Play sound, hit. Yeah, this is correct. I don't know why it doesn't play. It doesn't matter. We have our game. This is what I wanted to show you. Look, this is less than 150 lines of code to open a window to display bitmaps. If I wanted to, now let me show you a bit of things that I've done behind the scenes. So I really wanted this. I made this because I wanted this to run on a Windows 3.51 because I thought that's going to be really funny. But I got MacPixel to run on it just because I wrote it myself. But what happened is Windows 3.51 is a lot of these things that we're using here were not implemented back then because that's like 1992. So I tried and I couldn't manage to run it. But I did manage to run it on a Windows 98, and I will show you that in a moment. But there's a lot of things, different things that you could do with that. One of the things is software rendering. So if we had software rendering here, you might think, because now we're using system calls, system renders for that. The BitBlt function is famous because it can be provided by a driver. So now it's not a big deal because computers are fast. But back in 1992, when you had to draw the entire screen of Windows and your graphic card supported hardware acceleration of this BLT function, it was a big deal. So you did want to use, oh, that's Windows 98 booting, you know that. So you did want to have a system call because that was much faster than using software rendering. Now it doesn't matter. And look at this. If you create this added software rendering 100 more lines because the blitting function, this is loading bitmaps. Look, from the file with nothing. I do not need a library. Of course, there are a million libraries that you can use that will help you get your game to multiple platforms. But even if you don't, that's not much work. This is how much you need to create a bitmap. And to copy the bitmap is just this much of code. Look, this is blitting function. It's just a mem CPI that's with an alpha channel. That's it. That's all you need to have that running. And now, let me bring this screen here. If I go to my computer, I will show you that this runs. This runs really poorly, so it will glitch and it will blink. Can we turn off the sound for a bit? Thank you. All right. So I will go to C. This is really struggling. And I will open the main file. If it will open. Yes. It goes, here we go, the parameter is incorrect, but it doesn't matter. It's really glitchy because the CPU is too slow, and the TransparentBlt function was not implemented back in the Windows. You would have to do that manually. But look, this is the same thing that we built. It's just running on Windows 95, 98. So all of this you can have. You don't need that compatibility, but when you think about that, how hard would it be to write that from scratch even? It took us 45 minutes to write that from scratch. So maybe if we wrote that, we could have that for a different device, like here. I wrote it from scratch from MS-DOS when you weren't looking. So this is an exotic kind of situation because there's no more, you cannot find any more online courses on how to make DOS games. I mean, who makes them? But I was just like, hey, what if I wrote it from scratch for a different system to show you that this is not much work? Let me just boot up DOSBox so I can show you that this works on DOS. This is DOS. Here we go, DOS. All right. So I will go through the source code for you one at a time. So what you do in DOS, it's very simple. Is you have this pointer that you create to VGA. You do not allocate memory. It's just a pointer. You assign a number to it. And this number is like a location of memory. And when you put data there, it's going to appear as pixels. That's what happens. This is basically, it doesn't go to RAM. It goes to the VGA card, right into the memory, and it displays stuff. And then we just put it in numbers in the pointers to do that. The bits of assembly might sound scary, but they're not. This just sets the cursor position. You just do X, Y. Look, I mean, this is 5 lines of code. Move 02 to 8H. Move 0 to BH. Move this to X and this to Y. And then call function number 10. And the function number 10 is set cursor position. This is it. It might be difficult, but this is something you put once and you can use it forever, right? This clears the screen. I load the PCX file. It uses this much memory. And to blit it, it uses this much. Look at this. So now I have here the DOS that I will show you. This is running on the VGA on DOS as well. Can we have sound back on? Should be sound, maybe. There should be a PC speaker sound when I do that. And this is it. It took me 300 lines of code, and I had there's in Windows, you had the calls that you can load the libraries and stuff, and here I had to do everything myself. Even the sound, look, the sound, I just play the sound from a PC speaker, wait, and play a different sound to have a sliding motion. That's what you have to do in DOS. And still, all of this is less than 350 lines. It's around 350 lines. I just load the files, and then I render them. I do the same thing we did when we were working on on our project. But this is not all, because you can also have another thing. So do you know this? This is a Commodore 64, and even if you write the same thing for Commodore 64, this is still not much work. I will show you in a moment. So for example, let me just attach this cartridge image called black box. Things are very simple here. So you think that this Commodore, this is a difficult machine, but you can just print. I will print sauce. keys are in different places here. And then 20, I will go to 10. And then when I run this is the simplest app you can make. That's all right, it's in BASIC. But all right, you might say, all right, but you need assembly. All right, let's write assembly. You go into assembly language, we will write an assembly program. Look, because this is what the Commodore 64 is. It's just a 64 kilobytes of memory. This is our memory. This is the program that I just wrote right here. And then it just blocks. And these blocks, when you fill them with graphics and you point at the processor to look there, it will just draw stuff from you. You can this is like Matrix, but it's not that hard. Like, look, this is some code here. This is the code for the intro that we seen in a moment ago. This is the letters that were here. And now we're going to write our own. It looks really scary, but this is what computers used to be, and they're not difficult. Even this looks intimidating. Look at this. What I will do now, I will increase the number in register D0 to 0. That register is the color of the border of the screen. And now I will do jump back. And that's all I do. This is my program. It's in 1000 hex. That's 409896. So now I will call the machine language program at this address. Is that 96? Yes. And it will increase the border color and go back infinitely. This is how simple it is. And if you want to create stuff for the Commodore 64, let me just show you that it is not hard at all, because I have right here an assembly file for this game written in Commodore 64. You can do the same. Basically, what happens now, you don't need to load the file, because it's just, you just put it in the memory. You load the graphics into the memory. You load the window into memory, and that's all you do. You might think that this assembly language is difficult, but it's an old, simple computer. There is nothing difficult about it happening. And now let me just attach this for a moment and show you how this works. This might seem like a really odd choice of platforms to show in 2025, but what I want to show is that any platform, no matter how obscure, how old, how new, how different from what you know it is not a lot of time to create something for it, even without using. Look, we have ScreenShake for free. It also, Commodore 64 has hardware pixel perfect collision, so I don't have to do anything. I just check if the sprites are colliding. I can check that by polling the registers. I'm just like, are these sprites colliding? And they either are or not by perfect pixel arrangement. This is it. Remember, the creating things is not hard. And even though this looks difficult, I'm just like, look, I'm setting a color of a sprite here. I'm setting that the sprites are expanded. This is the game loop. I'm checking, here I'm checking somewhere the, I need to check the joystick, and I just checked if it's pressed left or right. I play the hit sound. I check the collision. I draw the sprite. I play the miss sound. This is, everything is simpler than you think. Like, look, I just put sprite. I will put sprite graphics in this, and I can point the system to it, and it will display it. I just put the sprite position into the register. Look, this is sprite coordinate for the sprites, and I just put number here, and it will draw the sprite whatever I want. This is the same with the notes. I just put the frequency in and be like, yeah, play note, and it plays note for me. And I set the, like, you know, the envelope, and it will play the envelope for me. I don't have to do anything. I don't have to do it every frame. And I will just check this number here in this DC00, and that's my joystick controls, right, left, right, down, and up. So yeah, this is it. We have made together this really nice, very simple game. I wanted to show you not to be afraid, even if things are different. Try it. You can use Unity, you can use Godot, you can use Unreal, but we are all here because we want to make games. We don't want to make a game. We want to make more games. And if you create an engine for your things, it's not much work. It's different, but it's not much work, and you will have it forever. I have created this engine that I made for MacPixel 3, and now I'm using it to create my next game, and I will use it to create my even next game. now I just have it. You can do that too for your company, for your business, and benefit from that. We have 10 minutes left, and I will take questions. I hope that wasn't too fast. I hope that was understandable, what we were doing here. At the end, I shown you a lot of stuff a bit faster, but I just wanted to show you not to be afraid, not to be intimidated by different platforms. If I used SDL, if I used libraries to load to display stuff, this would be like 3 times faster to do. All right. Do we have questions? We have time for questions, right?
Yeah, if you want to raise your hand.
Yeah, thank you.
Or, yes, applause first.
Anyone? I will also be, after we're done, I will be outside, and I will gladly talk to you in private if you're afraid of speaking up.
Hi,
yes.
Thanks for the talk.
Thank you.
I am meaning to ask, have you tried using C compiler for the C64?
No, because I know how to use assembly.
Okay.
I mean, this assembly is very easy, and the games you're making are very easy. If you want to make games for Commodore 65, learn the assembly. It only has 57 instructions. It can't even multiply or divide. Just adds. Anybody else? Was it clear? Can I get an okay that you were not missing anything? Okay, thank you very much again. Thank you for coming. If you want to talk to me, I will be around.